I would definitely put your name on this in case it gets lost. So the substitution method, this is a lot of writing here, sorry, apologizing already. This is a method of solving systems of equations. A method of solving systems of equations by, here's the key word, substituting equations within one another. A method of solving systems of equations by substituting equations within one another. Do you need a pencil? Yeah. You missing anyone today? It doesn't appear that way. Ira and Caitlin. I'm gonna open the window. Even sprinkling a tad. Oh dear. I made a contraption and I just broke it. I made a contraption with a rubber band so my window doesn't fly open. What do you need, Noah? I don't have any, but you can go see if they have some in the office. They keep telling me they don't. All right, so step one, remember we have to solve for X or Y. And then we're going to substitute this expression into the other equation and solve for the variable. So that is the pattern. Once we've solved for one equation or the other, we're going to substitute and solve. Then we're also going to substitute that answer into the revised equation from step one and solve for the other variable. Right? So this example is to solve each equation by substitution. So in place of this here, what y equals is going to go into where y is. So I would rewrite this as 2x minus 5. And then I would keep writing it as equals 4x minus 1. Do you see how we put what y equals in for y? That gets rid of our y variable so we can actually solve this. So now we have an equation with variables on both sides. I can either get rid of them from the left by subtracting 2x from both sides, or get rid of the variable term from the right and subtract 4x from both sides. I'd probably opt to do this, but you could go either direction. So this leaves it as negative 5 is equal to 2x minus 1. I now have a two-step equation, so I'm going to get rid of my constant first by taking the opposite of it from both sides. So I have negative 4 equals 2x. Divide by the coefficient. So negative 2, right? Negative 4 divided by 2 is negative 2 is equal to x. We're going to put this in for x. We can do it either way, but I would do it with the one with smaller numbers. I don't know. I guess they're about the same numbers. So y is equal to 2 times negative 2, because that's what x equals, minus 5. So this is negative 4 minus 5, which is negative 9. So my answer then to this system is the point, this is where they intersect, at -2, -9. All right, so this next bit helps us review graphing versus substitution. Notice these are the same systems, so we should get the same solution. If we're graphing this, I would start at the y-intercept of 6. 1, 2, 3, 4, 5, 6. Oh, these are little boxes, sorry. And the slope is 1, so I'm going up 1, over 1, up 1, over 1, or down 1, left 1. And you see where that goes. Hopefully you have a straight edge nearby, maybe your folder, your book, your planner, if you need a ruler. Thanks, Noah. That will help you draw this line here. Good review for how we would graph using slope-intercept form. Here we're starting at the y-intercept of -3. 1, 2, 3 below 0 here. And we're going to go down to right 1, down to right 1. When I make this, it's the same as going up to left 1, right? But we should see the point of intersection here, which looks to be at the x value of -3 and the y value of +3. So let's see what we get with substitution. We're going to put what y equals in for y here. So I have -2x minus 3 is equal to x plus 6. I'm going to go ahead and add 3x so I have a positive variable term. You can do it whichever way. So I have -3 equals 4x plus 6. When I get rid of my constant from both sides, oh no, what is happening? Oh, I see what I did. Look at what I did. Instead of adding 2x, I added 3x. So this should be a 3x. Nobody's hollering at me. Help me out. All right, so -9 here is equal to 3x then. That's better. I was like, I can't divide 9 by 4. And then I would divide by the coefficient. So -3 is equal to x. That's what we were counting on, right? So now, if I look at that top one, I have y equals -3 plus 6, which is 3. So this gives me the same point of -3, 3. All right? So 2 ways to find the solution. Sometimes you'll have the option, other times on the quiz they'll say, use this method, right? All right, so substitution, again, we're replacing what y equals with y. So I have 5x plus 33 is equal to 3x plus 19. I would move my variable terms to one side or the other first so that I have a two-step equation. So when I subtract 33 from both sides, I'm really thinking 33 minus 19, but I can put it in so that it comes out the way I want it. So -14 here is equal to 2x. I can solve for x easily, dividing both sides by 2. So if x equals -7, then y equals 3 times -7 plus 19. So y equals -21 plus 19, which looks like -2. So this is the point, -7, -2. All right. So we're going to have to be really good at solving equations with variables on both sides especially for these types of examples. So we're doing the same thing here. If both of these equal y, we can set them equal to each other, substituting 1 for y. So 7x plus 11 equals negative 2x plus 2. Get rid of a variable term from one side or the other by taking the opposite of it. So here we have 9x plus 11. We're left with just a 2 on the right. Got a two-step equation now, subtracting 11. 9x equals negative 9. Divide by your coefficient. X equals negative 1. So y has to equal looking at this top equation, negative 2 times negative 1 plus 2. So y equals 2 plus 2. We can do that. Right? Negative times a negative becomes positive, plus the 2, we have y equals 4. So this is the point, negative 1, 4. All right. We're going to do quite a few more examples. We're going to solve each by substitution. So we're putting in what y equals 4y. So we have 3x minus 7 is equal to negative 2x plus 18. I would probably add 2x to both sides, leaving us with x minus 7 is equal to 18. When we add 7, we're left with what x equals. That wasn't so bad. So 25 here. Oh, what did we do? Oh, I see what I did. I subtracted here. This is a 5x. This is a 5x. So I've got to divide by 5. Sorry. I'm really out of it this morning. All right, so x equals 5 here. So it can't be negative 5 or negative 5. So if I put that in, y equals 3 times 5 minus 7. Y equals 15 minus 7, which is 8. That gives me D. All right. So you're going to keep on keeping on. We're going to put this in place of the y, negative 7x minus 21 is equal to 8x plus 24. So I might add 7x to both sides. It gets kind of large. Negative 21 equals 15x plus 24. So if I subtract 24 from both sides, ew, what is happening here? Why is that so awful? So this gives me negative 44 equals 15x. What did I do wrong? Oh, nope, that's a 45. That's why. I just can't add. Oh boy. All right, divide both sides by 15. So negative 3 is equal to x. So it has to be this one. You can prove that by putting in a negative 3 in here. Negative 24 plus 24 is indeed 0. All right, but why not stop there if we can, right? So we're going to put this in for y. So we're setting these two equations equal. Since they're both equal to y, we can do that. Is equal to 5x minus 6. I'll probably add 3x to both sides. Negative 6 equals 8x minus 6. I'm like questioning everything I do now because Why do these all look weird? So if I add, oh, I see. If I add 6 to both sides, guess what happens? 0 is equal to 8x. So our x value has to be 0. So it cannot be c. That doesn't help a ton, but y has to equal negative 6 because 5 times 0 is 0. Minus 6, I should say. 0 minus 6 is negative 6. So that would give us this here. You'll get pretty good at looking back and substituting, but I do want you to show your work. Page 3, more examples. So here we're putting this in. Negative 3x plus 20 is equal to x minus 12. So if I add 3x here to both sides, I have 20 is equal to 4x minus 12. When I add 12 to both sides, I'm left with 32 equals 4x. Divide by the coefficient, so you end up with 8 equals x, which means if I look at the top equation, 8 minus 12 gives me y, which is negative 4. So the point 8, negative 4 is right here. I guess we could have stopped here because it was the only one with the x value of 8, huh? That was nice of them. All right, so we're setting these two equal just like we have. These are all in the same form, right? That's kind of nice. Negative 3x minus 6 is equal to negative 5x minus 14. I might add 5x to both sides to make them even. And by even, I really mean positive. It does happen to be even though. 2x minus 6 is equal to negative 14. When I add 6 to both sides, I end up with negative 8 on the right, 2x on the left, divide by 2, divide by 2. X is equal to negative 4, so it can't be negative 2 or 4. That leads us to y, which is negative 3 times negative 4 minus 6. So y equals 12 minus 6, which is 6. So that has to be A. Last example today, we're setting these equal to each other again because they're both in the form y equals negative 7x plus 4. Kind of wrote it backwards. I substituted this for this y that time. All right. So if I add 7x, I'm actually going to be left with just an x, which is nice. Here I have x plus 4 is equal to 4. Uh-oh, x is going to be 0 here. So it can't be C or D. So it looks like it should be 4, which is my y-intercept, the value when x equals 0. If you wanted to put it in to prove it, you could say negative 6 times 0 plus 4, or y equals 0 plus 4, which is 4. All right, so you have practiced then on pages 4 and 5 to complete. It is just 6 problems. And you've got about half an hour. So hopefully you can set those up and figure out what x is and figure out what y is. Lots of good practice there. Once you get done with that, make sure 6.3 has been completed in the reinforced packet. Work on Alex. All the things. Tomorrow, I will not be here, but the next few pages, you are gonna do pages 6 and 7, and then you're gonna complete pages 8 and 9. You can check your answers in the pixel art that will be posted tomorrow. So that's on the agenda tomorrow for when I am not here.